Hello, welcome to this video where I will be explaining how to evaluate water supply projects using WaterGEMS. Myself Tanay Kulkarni, I am a technical consultant for water at Bentley Systems. This video is typically for owner operators, utilities, infrastructure developers who basically outsource hydraulic modeling designs including DPR, that is detailed project reports, for water supply projects. Typically, the individual consultant or consultancy company designs this water network for optimal cost and benefits, and then they submit hard copies of DPR along with CAD and GIS drawings and hydraulic model and with other details, etc. The hydraulic model may be designed in WaterGEMS, WaterCAD, or even EPANET, etc. So similar softwares can be used for hydraulic modeling and its design, and then they submit the .wtg file or .inp file in soft copy to the infrastructure owner. Now this video is going to demonstrate on how to open these submitted hydraulic models in your WaterGEMS or WaterCAD and then check if any of the design constraints are violated. Now typically all the water infrastructure organizations have laid some standards based on which the water supply network must be designed. Now there are a couple of design constraints uh, which are the hydraulic model or the design is subjected to these constraints. Now these constraints consist of velocity constraint, that the velocity of the water in the pipe must not exceed 1.8 meters per second, or a pressure constraint, that you need to have a minimum residual pressure at all junctions across the operation zone, and it should not go beyond a particular limit of pressure. And then you may also have some head loss constraints or head loss gradient constraints while designing the water supply project. Now this video is also going to demonstrate on how to color code and annotate the network for various attributes of the elements such as pressure or velocity or head loss gradient, or any property of the element in your network for quick and better understanding of the design that was submitted by the consultant. Now this video will also help you understand how to evaluate various scenarios and alternatives and check whether the design stands good for those scenarios and alternatives. For example, a scenario may be, what will happen if you apply a peak factor of 3 for a particular operation zone, right? Was the design done with a peak factor or not? What will happen if you consider the 30th year criteria? What will happen if if you consider additional sub network in your existing water supply network, so on and so forth. So let us start. So let me open WaterGEMS. This is how a typical WaterGEMS window will look like. And the first thing that I always recommend to all the hydraulic modelers is to make sure that you are working in the proper unit system. So I just made sure that I am working in SI, and then let me in our case we have a submission of the network in .inp file, which is EPANET file, right? Now this submission file will be using WaterGEMS to open it and then to review that particular DMA network. Now if the consultant from the outsourced to whom the network design was outsourced, uses WaterCAD or WaterGEMS, you don't need to worry which version he or she has worked in, as long as you have the latest series of Bentley WaterGEMS. Now presently we have Select Series 6. Now even if the consultant has worked in Select Series 4 or 2 or 1, right, you can easily open those models without any conversion in Select Series 6. Now this is what Bentley offers. It offers forward compatibility. Now in our case we have EPUB file, so let us go to file and import, and you can see here you can import a WaterGEMS database. You can also import EPUB, right? So in our case we are going to import EPUB file. So now let us go and browse that particular submission. So this is the submitted EPUB network which we will be opening. Now it will take hardly 1 or 2 seconds to convert that EPUB file into a WaterGEMS file. Now as you can see, this is untitled1.wtg, that is, it's a WaterGEMS file now. And then you can simply click to file and save your network as submitted DMA. Okay, now make sure that make sure that your WaterGEMS file is will be saved in WTG format. All right. Now if now this is a big network, right? Instead of zooming in and taking a look where the tank is located at, you can simply use various tools which are there in WaterGEMS for quick understanding of the network. So we'll go to edit and we'll go to select by element, and now we are going to identify or understand where the source is. So the source in a network in a DMA is a tank. So let me click this tank. Now if I click this tank, it will select. Can you see the selection? So it has identified the location of the tank in this huge network. So I don't need to go on and check where the location of the tank is. I can simply use that select by element to understand where the tank is. Okay. Now there is another tool which is called as Network Navigator. You just need to go to View and Network Navigator. You can also use this shortcut Control 3 and open Network Navigator. In Network Navigator, can you see this greater than box? You just go here and you select all the tanks or all the pipes or all the junctions. You can, it helps a modeler or a person to identify and select only those elements which are in his or her interest. So let us now click this all tanks. So it has identified the total number of tanks where one element displayed, and if you double click this tank, it will zoom in to that particular tank. So you can also use this Network Navigator. Network Navigator can also be used for complex or interesting queries. For example, what is the shortest path between a junction A to junction B? Or you can trace upstream to the tank from any junction in the network, or you can trace downstream from a source to the farthest junction in the network, right? You can also use this tool in order to understand are there any pipes which are crossing each other, are there any junctions which are orphaned, that is, which are not connected to any pipe or any link, are there any dead end nodes, are there any pipes that are missing nodes or duplicate labels for pipes. So this is an interesting tool which can be helpful for understanding and evaluating the entire network. Now we have identified the source. Now you can just double click this tank and check from your data if the modeler or the consultant has used the elevations properly. Can you see the base elevation, the ground elevation, the minimum, maximum and initial elevations of the tank. Alright, so once you have confirmed this, you can use a tool which is called as flex table for understanding of the elevations that were used for the junctions. So you can either go to view and flex tables, or you'll find an icon like this on the screen. You just need to drop it down and select junction. Now once you select junction, it will give you all the junctions uh, ascending in order, laid ascending in order, and its corresponding ground elevation. You may also note that there are a couple of fields which are yellow in color, right? Now these fields are typically results field, and you cannot edit these fields, right? The white fields on the other hand are editable and are typically input fields for that particular element. So now you can see in tabular format what is the junction elevation that were used for the entire network. Similar to this, you can also review the entire project's design for pipelines using pipe flex table. Now if you see, it will give you pipe label laid ascending in ascending order, the start node, stop node of the pipe, the length of the pipe, and then the diameter of the pipe. Now again, diameter, material and Hazen-Williams C are the input, right? Typical inputs for the water supply network. But flow, velocity, head loss gradient and head loss are the typical outputs, and hence these are yellow in color. Now do not worry about the N/A text that you can see on in these fields, because as we have not yet computed the model, the software has not yet calculated the results for each and every pipe for these particular fields. Now once you have reviewed this, you simply need to go to analysis and validate the network. Now we typically validate the network in order to see whether any of the important property of the network is missing. For example, if the tank elevations are not inserted, then it's a big validation error. So let us now see if every input is valid or not. So let us click validate. Once we click validate, it will show us if there are any problems that needs to be catered. Now there were no problems during validation, and hence we are okay to compute this network. So now let us go to analysis and compute this network. Now once we compute this network, it will give us a summary of the calculation. Now as you can see here, it will show us what is the total flow demanded and the total flow stored. Now the total flow supplied is 0 because water was being drained out of the tank, and hence the flow, and a tank, mind you, the tank is a storage unit, right? And hence the total flow stored is negative 46 liters per second, right? So demand is equal to supply. So whatever the demand of water was, the stored flow from the tank was consumed in order to meet that particular demand. Now once you are done with this, you are also likely to be interested in understanding what peak factor was used for designing this network. So for understanding of the peak factor, you need to go to analysis and calculation options. You will find base calculation options. You just need to double click it, and under its properties you will find adjustments tab, and under adjustments you will find demand adjustments. Now you need to make sure whether the consultant has used any demand adjustment or not. So in our case, the consultant has used a demand adjustment. Now can you see this active? Once this is active, you will also find active demand adjustments, and in the active demand adjustment you have one item. If you click this ellipsis box over here, so here all the demands for the entire network were multiplied by a value of 3. That makes us understand that a peak factor of 3 was applied to entire all the demands. Now, how would we make sure that a peak factor of 3 is applied or not? For that, we can go to a tool which is called as Demand Control Center, and in Demand Control Center you will find all these demands. Now, just keep in mind that these demands are not subjected to the peak factor. You have explicitly applied the peak factor of 3 using demand adjustments. So if you click statistics on this demand base, you will get a total of 15.35 liters per second. Now this is your average demand. Now this average demand was multiplied by a peak factor of 3, and hence the demand which was uh, considered for design or for the computation of the network was 46. So 15 multiplied by 3 is approximately 45, and 15 point something multiplied by 3 is 46. I believe you got it. Now you may also be interested in having the diameters. You can go to individual pipe and select it and then check its diameter, or you can also go to flex table and pipe table and take a look at the diameters, optimal diameters that the consultant has provided. Alright, but this is not a very efficient way of understanding when you are trying to have a look at the entire network, right? So for that you will use this element symbology option over here, and in this what you can do is you can create annotations and color codes for the entire network for all the elements which are present in the network, and you can annotate and color code the network. For example, if we right click this pipe, let us color code this pipe on the basis of velocity constraint. Now for example, the field which we are going to consider is velocity, right? So you will select the field name as velocity, and what is your constraint? It should be more than 0, and it should be less than or equal to 1.8. So 1.8, if the velocity is less than 1.8 meters per second, then you have no objection. I mean, the design is suited. But if it goes above this range, you would like to have those pipes identified, so hence you would keep the color for those pipes as red. You can also use color and size option over here. So all the pipes which are having less than 1.8 meters per second velocity will be color coded green, and the size will be 1, which is normal. But the pipes which are going beyond this range will be having red color, and the size will be 3. Once you apply this, it will apply to all the network, and here you can easily take a look at the network and understand if any of the pipes is going beyond a range of 1.8. Now this is also possible when you go to flex tables. Now once you go to flex table, this is the velocity range. You just need to right click and click statistics. Once you click statistics, it will give you the minimum and maximum range of velocity, right? The maximum range of velocity is 1.07 in our case, which is less than 1.8 meters per second. If you are looking at 0.00, you can simply right click this and go to units and formatting, and you can increase the display precision, so it will give you some non-zero value of the velocity if there is a flow in the pipe. Okay, it will also give you an average velocity for entire network. Similar to this, all the flows are 0. You don't have to worry about it. You just need to right click it, click units and formatting, and you just select whatever units you are comfortable in. The consultant may be comfortable in liters per second, but the standard in your the standard unit for flow in your organization may be uh, liters per day, for example, right? And you just need to increase this display precision and click OK. So it will give you all the values of flow in liters per day. So you just need to make sure, I mean, make yourself comfortable using these units. Okay. Now once this is done, the other criteria that we generally are interested is the head loss criteria. So in India, the head loss criteria is defined in the terms of head loss gradient, and in CPHEEO, that is Central Public Health and Environmental Engineering Organization, has laid a constraint for head loss gradient that it should not be greater than, so it should not be greater than 10 meters per kilometer. So I'll select the head loss gradient field over here and make sure the units at present are meters per meter, so you just need to change it from meters to meter, meters by meter to meters by kilometer. And our ranges, if it's less than 10 meters per kilometer, the color code can be green, else the color code can be red. You can also select color and size option over here, and then you uncheck this velocity color code and you check this head loss gradient. Once you do this, it will show you if any of the pipe is having any violation for head loss condition. Okay, similar to this, you may also color code junctions on the basis of head loss, pressure. So the residual pressure in terms of meters of water, so I'll change the units to meters of water. I'll change the display precision to 2. So we'll calculate the full range. The minimum pressure is 0.22 meters of water and the maximum is 22.35. I can either initialize a complete range between this minimum and maximum and split it in 5 steps, or you can use a very basic condition. So if it's the value of pressure is less than 7, you would like to have red, because the minimum pressure criteria is minimum of 7 meters and the maximum of 22 meters. So if it's in the range of 7 to 22, the color will be blue, and if it's beyond 22, the color will be again red. As I told you earlier, you can use color and size option over here. So if it's less than 7, you would like to have 5 size for the junctions, because in order to understand in order to spot those junctions accurately, and you just need to click apply. Once you click apply, it will highlight all the junctions, like you can see on the drawing right now, all the junctions which are having pressure which is less than 7 and more than or more than 22, right? And then you can individually click these junctions and take a look at the pressure. So in this case, the pressure at this particular junction is 22.14. In this case, it's 3.29, right? So it has identified all the junctions which are violating the pressure constraint. Okay, and then you can take a decision whether to accept these drawings or to ask the consultant to improve and redesign the network. Okay, once you are done with this, so it has identified all the junctions which are having the pressure constraint, which are violating the pressure constraint. Then you can go to flex table and junctions table. Here you can apply a filter, and you can say that the pressure, if it is more if it is more than 22 show me all, I mean filter all the junctions which are having a pressure more than 22 meters of water. Let us click OK, and then it will show us only those junctions which are violating the pressure constraint on the higher side. Okay, similar to this, you can say that if the pressure is less than 7 meters of water, show me those junctions. So these are the junctions which are violating the minimum pressure constraint. Okay, once you are done reviewing this, you can simply go to filter and reset the filter so that it will give you all the junctions again in your list. Okay, so this is how you can understand the network. What interesting things that you can also do is you can annotate this network. Now you can annotate this network on the basis of physical properties like diameter, then another physical property like length, and physical property like the material that was used, property like the length of, sorry, uh, so and the results fields like what is the velocity in the network in that particular pipe, and what is the flow absolute value. Once you click OK and apply it to the network, click OK, and then when you go to any pipe, it will show you the summary of the results, or I mean labeled on those particular on all the pipes. So if I click this pipe, instead of going and reviewing the data from the property window, I can simply have it annotated onto the pipe itself. So this particular pipe is 138.4 mm in diameter. The length of the pipe is 277 meter, ductile iron pipe, and the velocity in the pipe is 0.7 something meters per second. The flow in the pipe is 10.97 liters per second. And similarly, it will do it for all the pipes in your network. Similar to this, you can color code and annotate the pipes for pressure. Now, once you are done reviewing this network, let us now go to flex table for any of the element on the network. Now these flex tables are very similar to Excel, but when your subordinate does not have WaterGEMS installed on his or her computer, you can simply copy these Excel results and paste it on a Excel sheet as quickly as that. So you can copy all the results from the WaterGEMS file from the flex tables and paste it on the Excel, and you can share this Excel with someone who does not have WaterGEMS installed on the computer. And now let us take a look at this interesting topic, scenarios and alternatives. We'll be now seeing how and what can be expected out of WaterGEMS file, and how can you demand more interesting designs and scenarios in one single file of WaterGEMS. In this particular network, we have a pump station over here which pumps water from this reservoir to multiple elevated storage reservoirs, like you can see over here, right? So this is one scenario for this particular small town, and the modeler can then create another scenario in order to understand what is happening on the distribution side of those elevated reservoirs. For example, this tank now distributes the water in the operation zone, right? All the pipes are color coded on the basis of the zone to which they belong, right? For example, all the yellow lines or the yellow pipes are belonging to Milind Nagar operation zone. Similarly, green pipes are belonging to Balaji Nagar operation zone, right? And then the modeler can, you can expect the modeler to create individual zone designs and individual scenarios. So this is the Bhaskar Bapu zone, in which you may have multiple DMAs. So you can expect these things in hydraulic modeling from the consultant or the designer, the to which you have outsourced the design, right? So I believe that I have covered all these points in this particular video demonstration. Thank you all for watching this video on water supply projects evaluation with WaterGEMS. Thank you very much. Have a good day.